Hello Longhorns, this is the Precalculus Test 5.2 review, and we will begin with number 1. So number 1 says find the component form of the magnitude of the vector w if the initial point is -3, 1 and the terminal point is 5, 6. Well, to find the component form, we need to find the difference between the x values of the component form and the y values. So what we're going to do is we're going to take the terminal side, x values, which is this 5, that's the terminal side, and I'm going to subtract a -3. This is going to give me my x value of my component. Let me erase that. Okay, so we're going to do 5 minus a -3. All right, the next thing we're going to do is find the difference in the y values of my vector. And the y values, the initial point is 1 and the terminal point is 6. So I'm going to do 6 minus 1 for the y value of my vector. So my vector in component form is going to be 5 minus a -3, which is 8, and 6 minus 1, which is 5. So the component form is 8, 5. Now once I have my vector in component form, this would be the end point of my vector, 8, 5. Once I have that, I can find my magnitude by using the Pythagorean theorem. So I know that this x value of my component form right here, this x value is the length of the x side or the horizontal side of my vector. So I can take that and square it. And then I'm going to add this 5 squared, the y value. So x squared plus y squared, take the square root. Well, that's just the Pythagorean theorem. So we end up with the square root of 64 plus 25, which is 89. The square root of 89 is approximately equal to 9.43. And I'm going to say units just because we don't really have a measurement here. But we're just going to go ahead and just say units on that. So that's all you have to do to find the component form of your vector given its endpoints and the magnitude. All right, for question 2, we're going to find the difference between 2w minus 3v. So we need to set this up with this multiplication first, and then we're going to subtract. So let's get this set up here. We're going to say 2 times w, and w is 4, 3. And then we're going to subtract 3 times v, and v is -2, 5. So we have to be careful that we're setting this up correctly and we don't get these switched backwards, because they gave us vw, but they're asking us for w minus v. So we had to switch them around. So don't let that throw you off when you're working a problem like this. Just pay attention to which one's w and which one is v. Okay, let's go ahead and do this multiplication first, and then we're going to subtract. So 2 times 4 here is 8, and 2 times 3 is 6. So 2 times vector w is 8, 6. Then we're going to subtract 3 times this other vector. So 3 times a -2 is -6. I'm going to keep that inside the vector symbol. And then 3 times 5 is 15. And I'm subtracting these two vectors from each other. So I'm going to subtract the corresponding components. So this is the x component. So I'm going to subtract 8 minus a -6. So my x component is going to be 8 minus a -6. That's going to be 14. And then my y component would be this other component, the second component of my vectors. So 6 minus 15, well, that's going to give me a -9. Okay, so when you're writing your vectors, don't forget to use vector symbols. I noticed in some of your homeworks that I graded that you were getting the numbers correctly, or you were getting your x and your y components correct, but you weren't using these vector symbols. You have to use these vector symbols to show that this is a vector, not just a coordinate. Okay, so that's very important to make sure that you're using these vector symbols right here. They're brackets. They look kind of like greater than and less than signs, but that's not what this is. It's a bracket that represents vectors. So you want to make sure you use that when you're showing the component form of your vector. All right, in question 3, we need to find the component form and the direction angle of this vector that's it's written as a linear combination. Okay, so this vector is actually just in component form. We would use this 2 as our y component, and this this 2 as our x component, and this -3 as our y component. So that's all it is for component form. So we're just taking this 2, and since this minus sign is really plus a negative, this would be, because usually we have a plus sign in our linear form, so this would actually be plus a -3. Because it's plus a -3, our component is -3. So we need to make sure that we write that as a -3. And that's just the component form of this vector that's written in as a linear combination. See, this is written as a linear combination right here. And so all we're doing is pulling this x value of 2 and then the y value of -3 and making it in a component form. So remember, component form includes these symbols that represent vector and component form. You need to make sure that you put those in your answer, otherwise your answer is not completely correct, and we'd have to take points off for that. So make sure you don't want to lose points over silly things like that. So just make sure you got your symbols in there so that you're not losing points for that. Okay, the next thing we're going to do is find the direction angle, and since we have an x side and a y side, we're going to use tangent inverse to find our angle. So we know that the tangent of the angle is going to be the y value over the x value, or opposite over adjacent. And since the -3 is going to be the opposite side of my angle and 2 is the adjacent side, I'm just going to use tangent inverse. So tangent inverse, and then I'm going to put in my ratio. Now, some of you on your homework, you got this upside down, and if you do it upside down, you don't have the correct function. You actually did a cotangent inverse, and that's not what we're doing. We're doing a tangent inverse, which is y over x. So it's -3 over 2, and that should give us theta. All right, so theta as a radian is going to be -0.9828. 0.9828, and that's if it's in radians. Now, if it's in radians, you need to do the conversion, and so you would multiply that 0.9828 radians by 180 over pi. And that'll give you the degrees. So if your calculator already gave you the degrees, it would look something like, oh, this is a negative, by the way, negative 0.9828. And so when we get the degree, we're going to multiply by 180, divide by pi, and we're going to get a -56 degrees approximately. All right, so we're still not finished yet, though. Even though we have a degree value here for -56 degrees, this is not the final answer. This is what we call a reference angle, okay? So this reference angle is what we're going to use to find the real angle. So what you want to do is you want to look at your component form of your vector to see which quadrant you're in. So just go ahead and draw a little picture for yourself, a little quadrant, and then put that point on your quadrant. Well, this is point 2, -3. So if I go over 2 and down 3, that puts the end point of my vector about right there. And that's located in quadrant 4. So if I'm located in quadrant 4, to get this angle measurement, that means I'm going to have to go from the standard position all the way around to quadrant 4. Well, that's at least 180 degrees plus another 180 degrees minus 56, because this would be our 56 degrees right here. So this is our -56 degrees right here. That's what the calculator gave us. But what we want is this other angle, the big one, the positive angle. So what we're going to do is we're going to take 360 degrees and we're going to add it to the -56 degrees, or you could say subtract 56 degrees. And that's going to give us the angle measurement that we're looking for, which is 304 degrees. So some of you on your homework, you stopped here. You stopped at this reference angle, but you can't stop there. That's a reference angle. Once you have the reference angle, then you need to figure out or calculate what the positive angle is going to be, or what the angle is supposed to be in that quadrant. So make sure you know what quadrant you're in, and make sure that the angle that you're getting falls in that quadrant. So in quadrant 1, we should get an angle between 0 and 90. In quadrant 2, we should get an angle between 90 and 180. In quadrant 3, we should get an angle between 180 and 270. And in quadrant 4, we should get an angle between 270 and 360. And our angle is 304, and we are in quadrant 4, so that's correct, and we can go on to the next problem. In problem 4, we're finding the dot product of vector u and vector v, where vector u is 4, -4, and vector v is -3, 1. Well, all we have to do here is we take our x values and we multiply them together. So take your x values, 4 and -3, you're going to multiply those together. And then you're going to add the product of the y values. So then we take our y values, these values right here, and we multiply those together. -4 times 1. So a -3 times 4 is a -12, and then a -4 times 1 is a -4. So -12 plus a -4, or we could say -12 minus 4, is -16. So our dot product should always be a single number by itself. The dot product is always a single number. For problem 5, we're going to find the angle between two vectors. So here we have vector u and vector v. And what I would like to do first is go ahead and draw a picture of what this might look like. And so we can kind of get an idea of what size of angle we're trying to find. And that might help us once we find our solution to see if our solution makes sense or not. So let me go ahead and draw a picture of the vectors that we have. Okay, so as you can see, I've drawn this vector u at -1, 3 right here. It ends up being in quadrant 2. And then vector v, the green one, which is 2, -4, that ends up being in quadrant 4. Well, you can see that this angle between the vectors, it looks like it's almost 180 degrees, but not quite. So we know we're looking for a value that's probably greater than 90, but less than 180 degrees. So we want to keep that in mind as we're working through our problem. Now, the formula we're going to use is going to be cosine inverse of the product of the vectors divided by the product of the magnitudes of the vectors. And that formula looks like this. All right, so what this cosine inverse is going to do for us is it's going to give us the angle that this is going to equal when we get done doing this computation. So the angle is this angle right here. We don't know what it is right now, but we're going to find out. And we're going to use this cosine inverse formula to do it. So first of all, we need to find the dot product of u and v, and then we need to find the magnitudes of u and v, and we need to multiply the magnitudes together. Then once we have that, we can put it all together with the cosine inverse, and then we'll get an angle measurement that is in between these two angles, between these two vectors. All right, so let's see what we've got so far. We found the dot product of u times v, so -1 times 2, -1 times 2 plus 3 times a -4, 3 times a -4. So this dot product here is going to be -2 plus a -12, which equals a -14. So we know that this u times v, this part right here, is -14. Then we found the magnitude of u. So to find the magnitude of u, I use the Pythagorean theorem, and I'm still seeing students not using parentheses when they do this, and you're still getting the wrong numbers underneath the radical. Please make sure that you're using parentheses with your negative numbers, because if you're getting a negative number right here for your answer, or you're getting some weird number for your answer, that would be why, okay? Make sure you're using parentheses around your negatives. So parenthesis, negative number, close parenthesis, then square, plus 3 squared. Okay, so this is 9 plus 1. 9 plus 1 is 10. So if you need to do it in your head, do it in your head. If you're going to use a calculator, make sure you're using parentheses. Okay, next one is the magnitude of v. The magnitude of v is 3 squared plus a -4 squared. Again, I have a negative number in parentheses squared. I'm still seeing students, homework after homework after homework, not using parentheses around this negative, and you end up with a negative number inside the radical. I guarantee you, if you're getting a negative number inside this radical, it's because you're not using parentheses. I'm going to know it, and now you're going to know it, okay? Do not get a negative sign inside this parenthesis. So this is square root of 25. I can go ahead and simplify that to 5, so I'm going to. So it'll just make it easier for me. I don't need to keep that as a square root of 25. I could if I wanted to, but it doesn't really matter. It just makes it just simplify it. Okay, so now what we're going to do is we're going to take our parts, this -14, which is the part of our numerator, and then this 5 times this root 10, which is going to be this part of my denominator, and I'm going to do the cosine inverse of that ratio, and that's going to give me my angle measurement. All right, so as I was writing my cosine inverse, I realized that I made a mistake right here with my vector. Don't make this mistake, please. Check and make sure that you have the right numbers for your vector. This is my vector v. So to find the magnitude of vector v, I need 2 squared plus a -4 squared in parentheses. So this actually gives me square root of 20, not square root of 25. Okay, so sorry about that mistake. Be careful of that. Make sure you're looking back at your vector, not at these numbers here. See, that's the mistake I made, is I looked here instead of up here. So make sure that you're looking back up here to your vector and that you're putting your vector in for your magnitude, not your dot product. Okay, so don't make that mistake, please. All right, so 2 squared plus a -4 squared is going to give me a square root of 20. So this is what's going to be in the denominator, a root 10 times a root 20. Now I could rewrite that, and I could go ahead and multiply those together and call that root 200. So I might do that just to make it easier to put in my calculator. All right, so I put the -14 in the numerator and the square root of 200 in the denominator. I did a cosine inverse of this ratio, and it gave me approximately 3 radians if my calculator is in radians. If you do get a radian measure, then you need to multiply by 180, divide by pi, and that'll give you approximately 172 degrees, which makes sense because didn't we say that we knew it was going to be almost 180 but not quite? Well, that makes sense then because this is 172 degrees. So we know that we're approximately correct here. So if we had something different than that, then we would have to double check our work and make sure we didn't make any silly mistakes like I made right here, just double check all of your work and make sure that you've got what needs to be in the magnitude formula and that you've done the dot product correctly. So remember, it's x times x plus y times y. And that's it. All right, in the next problem, we're stating whether vector w and vector k are parallel, orthogonal, or neither. Okay, so we can do a quick check for parallel by putting y over x. So y over x for w is going to give us y over x, 7 over negative 7. That equals a negative 1. So the slope for w is negative 1. And the slope for k is 1/5. So they are not parallel. And to check to see if something is orthogonal, we do a dot product. So we're going to do a dot product of w and k. So negative 7 times 5 plus 7 times 1. We're going to do this dot product, and here we get negative 35 plus 7, and negative 35 plus 7 is going to give us a 28. Negative 28. And that is not orthogonal, because in order for it to be orthogonal, it needs to be a dot product of 0. And this is not a dot product of 0. So remember, orthogonal means perpendicular, and perpendicular makes a 90-degree angle. And the cosine of 0 is 90. So in order for this to be orthogonal, this dot product right here that we get, the answer we get when we do the dot product needs to be 0. If it's not, then it's not orthogonal. So we would have to say that this one is neither. And that's all you have to do. Those are the two tests that you have to do. One for parallel, one for orthogonal, and if it's not either one of those, then it's neither. Number 7 says, let the magnitude of the vector be 77, and the angle, the direction angle for the vector is 74 degrees. Write the vector in component form. Okay, so we learned in class that if we take the magnitude of the vector and we multiply it times the cosine of the angle that we're given, that's going to give us the x value of our vector. That's going to equal x. And if we do the same thing but use the sine, because sine would be the side opposite, and we do this of the angle, then we get the y value of the vector. So when I put this in my calculator, the values I get are 21.2 for the x value and 74 for the y value. 21.2, and I could round that to 21 probably, and I would be okay with that. And then 74 for the y. All right, problem 8, we have a 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base. What is the angle of depression from the top of the tower to the point on the ground where the cable is tied? All right, so we're going to draw a picture. All right, so I've drawn a picture. This is my 50-meter tower, and then this is my cable. And it's tied down here 30 meters from the base of the tower. And the angle of depression is this angle right here that is from the horizontal looking down. So if I was standing up here and I was looking down, this would be my angle of depression. So the angle of depression is the same angle as this angle of elevation if I was standing down here at the bottom. So if I was standing down here looking up, my angle of elevation would be the same thing as if I was standing up here looking down and getting an angle of depression. So these two angles are the same. So because they're the same, then I can use my right triangle trigonometry to help me with this problem. So here I can use tangent inverse, and I want to be very careful about the ratio that I'm using. I want to make sure that I'm using the side opposite over side adjacent for tangent. So side opposite in this case is going to be 50, because 50 is the side opposite of this angle right here. Okay, and since this angle is the same as my angle of depression, then I'm going to use 50 over 30 as my ratio. 50 over 30. So 50 over 30 is going to be my tangent. And my tangent inverse gives me 1.03 radians. And I need to convert those to degrees. So I multiply times 180 divided by pi. And so my degrees ends up being approximately 59 degrees. And that's it. That's my angle of depression. So in problem 9, we have a radio tower 200 feet high, casts a shadow 75 feet long. What is the angle of elevation of the sun? Well, this is just like the last one we did. So we're going to do tangent inverse. Side opposite of my angle of elevation is going to be 200 feet over side adjacent, which is the side that touches the angle, 75 feet. And the radian I get here is 1.21 radians. And then when I convert that to degrees, I get times 180 divided by pi. I get approximately 69.4 degrees. And that would be my angle of elevation. All right, for problem 10, we're going to find B. Well, first of all, you need to label your triangle because right now the triangle is not completely labeled. And I noticed that some of you still don't know the proper way to label the triangle. The sides are going to be opposite their corresponding angles. So side B is going to be opposite angle B. Side C is going to be opposite angle C. Let me just draw some arrows here so you can see, okay, what I'm talking about. And then side A is opposite angle A. And we need to know that because if we're going to use the law of sines to find a side or an angle, we need to know which sides correspond to which angles. So it's really important for you to go ahead and label your triangle so that you don't get that mixed up. Okay, so we're going to use the law of sines in this one. And I'm going to say that side B over the sine of B, which is the sine of 42 degrees, is going to be equal to 12 over the sine of A, which is the sine of 63 degrees. And I'm just going to cross multiply that and pop that in my calculator. And that's all I have to do for this problem. It's super simple. So just make sure you don't forget to put your sine 63 degrees, and don't just put 63 because that's not going to be correct. It's the sine of 63. So this part, if you want, you can use parentheses. I don't think you really need to. In the calculator, I think it takes care of that for you, but you'll want to go ahead and put them in if you want to. It doesn't matter. All right, so when you put that in your calculator, it's going to give you approximately 9 units. And that's all there is. Last but certainly not least is question 11. Question 11 has 2 parts, and it should say A and B, but it says A and C, and that's okay, just a typo, no biggie. We're going to do 2 different problems where we're solving for an angle. So this right here is the angle that we're solving for, and the answers that we're going to give are going to be in radian measures from our unit circle. So when you're solving for this angle measurement, remember it's some angle measurement like pi over 6, pi over 4, pi over 3, pi over 2, one of those angle measurements from your unit circle. So you're going to need your unit circle for this one if you don't have it memorized. All right, so the first step is to go ahead and solve this just like if it was, you could change this sine A. If you want to, just change it to X. If that helps you solve, then do that. Just remember to change it back to sine alpha when you're done, okay? So if this helps you to solve for sine alpha, then just do that. So I'm going to solve for x like I would always solve for x. So 4x equals 2 because I'm adding 2 to both sides. Then I divide by 4. and I get x equals 2 over 4, or 1/2. So remember, I'm looking for, and I'm changing my x now, I'm going to change it back to sine alpha, because that's what we're really doing here. Sine alpha is 1/2. So what I'm going to do now is I'm going to look on my unit circle, and I'm going to look to see where the sine value is 1/2. At what angles, or what angle measurements, is the sine value equal to 1/2. Now remember, the sine value is the y value in your coordinates around the circumference of your circle. So as we're going around, the sine value for what angles is the sine value 1/2? So we find that the sine value is 1/2 at pi over 6 and 5 pi over 6. Okay, so these would be the angles in quadrant 1 and quadrant 2. So sine is not positive in quadrants 3 or 4, because remember, y values in quadrants 3 and 4 are negative. So we would not include any angles from quadrants 3 or 4. Okay, so let's go ahead and do this one down here, 3 tangent squared alpha minus 1. Okay, once again, if you want to change tangent squared alpha to x squared, if that helps you solve and it makes it easier for you to understand it, then do that. Just don't forget at the end that you need to change your x back to tangent alpha, okay? So here we're going to add 1. That gives us 3x equals 1, and then we're going to divide by 3. So this is x squared equals 1/3. And now what happens here is when I take the square root of both sides, you want to watch out here. This is important. I'm going to get x equals the square root of 1 over the square root of 3, and not only that, but it's plus or minus. And that's real important, because that's actually going to give us more solutions than we normally would have. So because it's positive or negative, that means that my angle measurement could be in any quadrant. So what I have to do here, though, is I have to rationalize my denominator here, because I have a root in my denominator, and the values around my unit circle don't have any roots in the denominator. They've all been rationalized. So we need to rationalize these as well. So what we end up with is root 3 over 3. So I'm looking for all the angles where tangent, so remember we said that x was tangent, so we're going to say tangent of theta, or alpha, this is alpha, is equal to plus or minus root 3 over 3. So where does that happen on my unit circle? So you want to look at your unit circle, and you want to write down all the angles where tangent is plus or minus root 3 over 3. Well, that's going to be in every quadrant. We're going to have one. So in quadrant 1, that value is pi over 6. In quadrant 2, the value is 5 pi over 6. In quadrant 3, the value is 7 pi over 6. And in quadrant 4, it's 11 pi over 6. So we actually have 4 angles where the value of tangent is plus or minus root 3 over 3. And that's it. Good luck on your test. Make sure you practice. Go back over your homework problems again. Look back at them again and make sure that you've done them correctly. If you have any questions, please come and see me in tutorials before or after school. Also, I will be in my room during B-lunch. I'll be eating my lunch, but you can pop in if you have a quick question. I don't mind answering quick questions. Or you can come before or after school for tutorials if you need more help before the test on Tuesday. Good luck.